what characters appear where and things like that. So for instance, if you had a block of text and you want to pull out all the email addresses, regular expressions are a very good way of doing that, and that's built into JavaScript. You've got iterators and conditionals, which you'll find in every language, things like if-else statements, for loops, and so on. The math object, as I've said, which allows us to do a lot of mathematical functions like square rooting, powers, and so on. And of course, you can define your own define your own functions within JavaScript using the built-in stuff if you want to create something specific for your use case. Some of the frameworks which are available: Prototype, which is the one we're going to use today, which it's not as popular as some of the others, but I like it because I like the syntax of it. jQuery, which is probably the most popular, and YUI, which is written by Yahoo. So that's what powers a lot of Yahoo applications like the Yahoo Calendar, Yahoo Mail. All of the Ajax for the interface and all of the JavaScript behind that interface is built upon YUI, and that's the same one they use in Moodle as well. So I know that one quite well. Web services, as I say, they're not just there as a source of data. Some of them can do processing for you. So if you get a postcode, for instance, from user input, you could then send that to Google Maps using it as a web service, or OpenStreetMap, and it could give you a map back just by processing the postcode, working out where it is, and giving you the stuff to present. In terms of output, the web is designed to output documents, text, images, multimedia, whatever you want. And because we're using web technologies, we've got all those things available to us. So you could just want to output raw data. If someone was using a calculator, you could just output some raw data. You could output some plain text if you wanted. You could format some text using HTML. You could do something a bit more flashy. You could use HTML video or audio tags if you had done some, say, audio processing in JavaScript, which is possible. It's quite complicated, but I've seen it done. So you could take input from a microphone, for instance, and put a filter on it and then play it back using HTML5. You could use SVG to display vector graphics. You could use Canvas to display bitmap graphics. So if you had a webcam, for instance, you could take pictures on the webcam using HTML5. And again, you could use a web service if you wanted to publish data somewhere. Yeah, so I've just been through most of this, but yeah, again, raw data, if you were just displaying a digital clock, you might want to present it a bit more nicely, but if you just wanted the time, just straightforward, you could just dump the time straight on the page. Oh, sorry, this one's blown out a bit on the projector. But for HTML, there's two real ways of doing it. You can build a string of HTML tags, which is the way we're going to be doing it in the lab initially. So there, it's just like typing HTML, except you include the data in the string, and then you output it to the page. There's also a method called the document object model, which we're looking at in one of the advanced exercises, where you use an object-oriented API to build up each element. So here you can see, rather than just having an opening tag for each one, putting data inside, and then over here you can't see it, but you have to have a closing tag for each one as well. You just create the element within the page. So you create an unordered list element, then you create a list item element, and then you create a text element, and then you attach the text element to the list item, and you attach the list item to the list, and then you attach the list to the document. Now that's quite complicated. It's not as straightforward as just doing it as a string, and it's a bit counterintuitive because you have to you work almost inside out. You create everything from the top down, but then you stick everything together from the bottom up. Otherwise you can't append stuff on afterwards. But it does mean that you get properly formatted HTML or XML, depending on what you're doing, and you don't get a chance of human error. You might not accidentally leave the slash off a closing tag or something like that. Web services, again, they, as I said, they don't have to be for data. They don't just have to be for data and processing. They can be for publishing as well. So say you've taken a photo on your phone using the widget, which has displayed it to you. You could then upload it to Flickr using their web service, or you could write a message and then you could post it to Twitter using their web service. Lots of sort of social network sites have web services which allow you to publish to them as well as getting things from them. Just a note about using web services, because I've shown a few examples of where you can use them. They require network connectivity, obviously, because they're on the web. So if you're going to be relying on a web service for your widget's functionality, you need to think about where it will be used. If it's only ever going to be displayed on the web page, that's fine. But if it's, say, going to be displayed on the mobile phone, then you might want to think about whether everyone's going to have a contract with 3G, or whether they're always going to be somewhere with signal where they can connect to the internet. And if it's possible, can you provide offline functionality to do what you would otherwise do? For instance, can you cache the data which you'd be requesting from the web service, so at least they've got something to work with, even if they can't get fresh data? Or can you write a routine which will do some of the processing that a web service would normally do if you don't have access to the web service, things like that. Again, sometimes it's not going to be possible, it's going to be relying on the web service, and that's fine. You just need to make sure that you think about it when you're deciding where to publish your widget. Right, so I'm just going to quickly go over what we're going to do in the lab. What we're going to do is use a web service which I've created, which will give us the top 10 metal albums in order of, well, it won't give us the top 10 metal albums in order of sales. It'll give us the top 10 metal albums. I've chosen metal because I like metal. I'm sorry if that offends anybody. Basically, the web service is going to return us the top 10 albums as an array of JSON data. They won't be in order, but they will have the number of sales which they've each had with them, which means that we can process it and get them in the order we want. So the data is going to have to be fetched from the web service. We're going to need to parse it so that we can use the data. We're going to have to sort it into the right order, and then we're going to have to present it to the user. And once you've seen how to do this, you start to see how you can use it for doing other sort of applications. So you might want to create something which monitors a server, or monitors network traffic, monitors firewall rules, things like that. So yeah, as I say, we'll be starting shortly after 1 o'clock doing that, and you'll have a worksheet to work through, and we'll be around to help you out as you need it. Right, that's the end of the presentation. Thanks for listening. If you want a copy of these slides, you can go to that link there, or take a photo of that on your smartphone, and it should give you a copy of them. It is just web-based, so it will run in your browser. You don't need to download a PowerPoint file or anything like that. And as I say, my email address and my Twitter are there if you need to get in touch with me.